Hi, Samira. This is my comment set for Lab 5. Most of this you've already done. As in Task 1, you have already done the changes to the. I've highlighted them in yellow, so they're easy. You've done that one, you've done that one, and in the summary, I have made some graphs for you, and here is a description of the graph that I have made. First task, she asked for a graph of the total radiation that's coming down onto each layer. So that's the solar radiation plus the radiation coming from the layer above it. And there is no layer above layer 1, so it's just the solar radiation. Layer 2 is the solar radiation plus whatever heat is coming down from layer 1. Layer 3 is solar radiation plus so it goes on and on like that. Now, the next graph that she asked for was the uh, the upward radiation. And she said you could put them on the same graph or you could put them on separate graphs. So I have put them on, and I've also put them on the same graph. You can use one that you prefer. So on the same graph, you notice that the upward radiation is always larger than the downward radiation, which is a surprise. Same. Radiation is coming from the radiation is coming from the sun only. Radiation is two. Two, the downward radiation is coming from the upward radiation is coming. See, layer 3 was hotter than it gets warmer and warmer, of course. So that was a surprise. Same upward and downward radiation, but that I stated that in the hypotheses and in the discussion as she requested. Now, just in case I was interpreting that wrongly, here I think I have interpreted the instructions correctly. I don't think this is something that we need to. Layer model assumes that the clouds and the albedo, as they say in the Archer book. We need to delete this entire thing, delete this data, and delete this graph. But just in case I'm interpreting that wrong, I put this in here. Albedo is 30%. It's 236.25. 1350 is the incoming solar radiation. 236, the um, the other difference between on the previous graph, which I think is more correct. Two, layer 2, I have the down onto layer 2, not uh, up to layer 2 from layer 3, not up from layer 2. And so I think this is what she wanted. But just in case I'm wrong, I have included the other graph if you want to, if you have a different idea about that. So in this graph, there is not um, below the ground. So you can't, in the has a task after task 2. Task 3, she asks for the features, responds to these sheet as activity equals 1. The first, but in the third task, last task, she's asking. So I just reproduced this entire file right here. So the layers are here: layer 1, layer 2, layer 3, layer 4, layer 5, and the ground. The incoming solar radiation that was given. This is without the albedo and etc. And temperature coming from the layer above. Now, there is no layer above 1, so this is blank. And there is no layer above 1, so this is also blank. This is the temperature coming from the layer above, and this is the heat energy that is coming from the layer above because it has that temperature. Use the same formulas as used in the rest of the file. This is the Stefan-Boltzmann equation up here that I'm using there. The ground temperature is right here. Here, I'll put this in bold so you can see. Um, these are the ground temperatures. These ground temperatures are the temperatures that I put right here. These numbers format for you. Format cells, right? And I'll do that over here too. So I'll change the format to a more usual format instead of scientific notation. I don't know why it has the scientific notation there. Maybe because there wasn't enough space. So that's the more normal notation. These are the ground temperatures. This is for emissivity equal to 0.4. You see that? This one is for emissivity equal to 0.5. The ground temperature is that. This is for emissivity equal to 0.6. The ground temperature is that. That's for emissivity equal to 0.7. The ground temperature is that. And etc. Put this in bold so you can see what I've done here. Now this should be not 0.1. This is just 1. Emissivity equal to 1. Okay. And that's all. Thank you very much. That was an interesting lab project. It was confusing, but still interesting.